Y'all coming up? Y'all okay?
I'm trying to diagnose this. It's saying incorrect syntax near the keyword case, and I have no syntax there, so.
I bet y'all know what it
that's
is.
Right.
Huh?
You say you know what it is?
I bet y'all do. Do you have your period? I mean, not your period. Your comma in between your before you start your case statement, just like this.
Oh, it's not after it. Okay, there it is.
Oh, I forgot. Name your column test result.
Oh, because I sure named it patient status.
That's cool. Whatever, because sometimes I think that's a good name as well. Whatever it is that captures your analysis, that's cool. That is cool. Perfect. Okay. Did you figure out your syntax error?
Yep.
Okay. Do you have any questions? You or Ashley, y'all have any questions?
No, I have my results pulled up.
Okay, so you were able to execute it. Do you mind sharing your screen? Ashley, are you good? Ashley T. LaShawna, do you mind sharing your screen? Or you want me to share mine? Okay. I see your code. Oh, this looks good. Okay. The only thing I would recommend you do is to get rid of that top 100. I mean, top 1,000. But other than that, this is perfect. Do you get why I'm telling you to get rid of that top 1,000?
Because it takes out some of the useful data.
Yes. You look in the bottom right corner down here, you only have 1,000 rows of data. So, yep. That's top, there you go. Perfect. Now, if I was to say, I want this, oh, this is so clean. This is cleaner than mine, actually. If I was to say, Lashana, I only want patients analyzed that have an abnormal MRI test. What would you do?
Oh my goodness, I forgot. Hold on.
Let me share my screen. It is not off base. That's very good. You did an excellent job. Your data's chef's kiss. Your code looks good. Now I'm gonna share my screen. Okay. So if I say I only want an output of patients who have had an abnormal MRI test, I would capture that here. That's when I would start filtering out my data. So you got your logic. Now let's build on that logic. I said, okay, perfect. That's where you would get into those logical operators. I would say I have my condition, I have my case statement here, I have my logic here. Case, when, this column equals this. This ain't nothing but a condition. But we're embedding the condition in our syntax as opposed to using it as a filter. So I say case, when this column equals this value, then we're gonna call it that. When, then, then you just keep going. And then I said, you know what? I only need people who have an abnormal MRI test. That's all I want. That would require for me to start filtering my data. I come right down here and I filter my data. Where this column equals this, and this column equals this. So I get extremely explicit in what data do I need. Any questions on this case logic? Okay. No news is good news. Oh, Lashana, was you saying something?
Sorry, I was, huh?
Were you saying something?
No, I was playing with the different statuses.
Yeah.
Pull up different results.
Does that help you? Do you see? Okay, when I say once you understand the logic, most everything in SQL is relational, like literally. So once you understand that core logic, anything that you will pretty much learn is going to be an extension of like something that you already know. And it is like the more you play with it, the more it's like, okay, I'm essentially just layering it. Like I look at it like lasagna because like I be replaying everything back to food. But to me, it's like when you're cooking or when you're doing anything, you literally start from the base. And then it's like, okay, this works. Now let me add that. Okay, this works. Now let me add this. And you just keep going until you get your expected output or outcome if you're cooking. Same concept. Yep. Ashley T, are you good? I don't know if you're talking or not because I saw you go off mute and I don't want to leave you out. But if you just type it in the chat. So The next objective is joins. Joins. So there are, I always say there are times, because most of the time, if you are responsible for analyzing data, most of the time your data is not going to come from only one table. That's like almost unheard of. Oh, Ashley gone. Okay. That is almost unheard of. So with that being said, it is a requirement or will be a requirement for you to join multiple tables in order to pretty much do your analysis. Now, this is also why I'm so hard on y'all about data relationships, because data relationships drive joins. The relationships of multiple tables, that is how I'm going to join my data. I can't just be the randomly pulling tables together. I have to make it has to make sense. The math got to math. So in order for you to join multiple tables together, you have to do that on a data relationship or a common field. What's the common field between these multiple tables that I'm able to join these together and answer this question? Now, going back to what I always say, once you fully understand one thing within data, you're able to leverage it all the way around. Power BI does the merge. It's called merge. I'm taking this data set and I'm merging it with this one. Python does the same thing. I'm joining these multiple data sets and I'm putting them together. So they all pretty much are. Ashley, you good? I don't know, Ashley. So, if you talking, I can't hear you. So um they all pretty much depend upon like one another regarding like oh she gone again regarding the data relationships. So let's get into joins. So there are four types of joins. Now, I always tell y'all that there are multiple ways that you do your technical assessment. One way you do it, you might have to write your code live, similarly to how we do it here. I'm giving you some data, you go through, you talk through your concepts. Okay, now I'm doing my data investigation. I see that these tables are related on this field. You talk through it that way, and you might have to write code. Another way you might have to do a technical assessment is just questions. Like somebody might just ask you a few questions just to gauge your understanding of SQL. One common question that is typically asked is, what are the four types of joins? So when you are in a position when you are starting to interview, when you are starting to get out there, have something that you can reference and point back to understand what these joins are and how they behave. Um, Now, also a little disclaimer: I was actually a senior data analyst, and I was still struggling with joins, and not in a way that like they're not hard, but it was just in a way that it was hard for me to understand the concept of them. But the way that I explained it to y'all is like the way that I understand it like now to this day, which is to me the easiest way. Um, so let's get into joins. There are four different types of joins. You have your left join, your inner join, your right join, and your full outer join. So within your left join, the way that your left join behaves is going to take all of your data from your left table and matching data from your right table. Left table, all your data from your left table, matching data from your right table. What is a left table? What is a right table? A left table is the table to the left of your join statement. When you write your code, you determine what's a left and a right table based on your code, based on your code. Left join, all your data from your left table, matching data from your right table. If that data does not exist in your right table, in your left table, it's not coming back. Inner join. Inner join only brings back common data from both tables. Does this data exist in this table? Also, does this data exist within this table? If that data exists in both of those tables, it's going to show up in the output. Right join. All your data from your right table, matching data from your left table. Meaning all this data from this table, and if that data exists within that left table, bring it over. Full outer join. Full outer join brings back all the data, regardless on if there is a match or not. Your bread and butter is going to be your left join and your inner join. These two here are going to be your go-to. I've never written no right outer join. And I'm going to tell you why. Because naturally, when we read left to right. When we write left to right. If I have a table that I'm prioritizing the data in that table, I'm going to list that table first. Just naturally. That's how we do things in the English language. So you won't be using a right outer join, but you need to know what it does and how it behaves. Because like I said, it's a common question. I've never done a full outer join because technically when you think about if I'm pulling all of this data, regardless on if I have a match or not, what kind of analysis am I going to be able to do from that? If I'm getting all this data, all data is not really good data. Also, let's say I have a table with, let's say I got a table with 30 columns and 2.5 million records. That full outer join does not care. It's going to pull all that data over. And that's not good for the environment or your database. It's not good for that. And it's also not very helpful either. Any questions on that? Okay. Now let's get into our syntax. So here we have our inner join. Remember, our inner join only brings back common data from both of those tables. What data exists in this table and what data exists in this table. I want it back in my output. So here we have select. We've been selecting. This ain't nothing new. We've been doing this. Select. This is where things get a little tricky. So we got select. We have e.name. What is this? This e.name, this e is an alias. No different than how in our aggregate functions, we said we're going to name this column this. In our case statements, we're going to end as this. Those are aliases as well. I know that you call it this, but let's call it that. I know that it's originally this, but let's call it that. This E is an alias. And where it is sourced from is, I'm saying I have named this table E. Mind you, you can name your table whatever you want to name your table. I've seen people do numbers. I've also seen people like go literally A, B, C, because you can have multiple joins on multiple tables. But for me, the way that my brain rationalizes this is I name my tables based on whatever the table name is because it helps me like easily identify it. So here I got e.name. I'm essentially saying I'm pulling the name column from the E table. Inner join my department table, which I have named D. So I'm goofy. I don't know why I thought his name D. But anyway, okay, let me stay focused. But I'm essentially saying I'm pulling the department name column from my D table, which is this table. So I'm selecting column. This is what we've been doing. From this table, I name my table E. I'm interjoining these two tables. I'm telling it interjoin. Now, this is where you get into your data relationships. This is why also every time you all get within a database, I'm like, go and do your data investigation. Go and see which tables exist, or go and see which table columns are relational, because it comes in handy when you are joining these tables. Because I'm having to tell it, join these tables on what though? On these fields, on E dot department ID, on department ID from my E table equals D dot department ID, my department ID from my department table. Down here, I have my employees table. These are my columns in my employees table. I got my employee ID, name, and department ID. I got my department table here, department ID and department name. So when I'm looking at these two tables, what's the data relationship?
The department ID.
Yep, that's the department ID. And that's why I'm joining these two tables on this common field. What is the data relationship? Select column from tables. Interjoin table. On what though? What's the common field? Department ID. That's the common field in both of those tables. Now, if you recall an inner join only brings back common data between both of those tables. What data exists within this table and what data exists within this table? Whatever data exists within both of those tables, I want that data in my output. This is the result. Now, I'm pulling over the name. I'm pulling over the department name. What records are not pulled over here and why? When I'm looking at this employee table, I'm looking at all this data in this table. Then I turn around over here and I look at all this data in my department table. What data does not exist? What data is not populated in my output and why? Not the columns, because I'm pulling over the name and department name. I got that. But what records are not showing up in my output? And why?
Will we exclude